In the previous video, we discussed about fundamentals of data communications. We gave you what is the data communication, what is the data, what are basic features of data communications, how data can be represented. Data can be represented in form of a image, data can be represented as a video, data can be represented as a text, data represented this one. We also give you that when you have to send your data from one to another, there is the basic element is the transmitter and the receiver. There must be some kinds of media, there must be some information to be exchanged, and also the most important component of data communication is that there should be some kind of protocol to coordinate or to synchronize all the activities between senders and receivers. Now, for example, when you send an email, there is a protocol for sending an email. When you do video streaming, again there is a protocol for video streaming. When you surf the net, there is also a protocol. So for every activity you do as a part of data communication, it is basically some kinds of protocols are built into this mechanism. We also made a point that the earlier system didn't have a data communication facility. They were basically on a standalone systems. Although PC brought lots of computing changes, our style of computing, but it is the data communications facility built into a system brought lots of changes rapidly. Now we'll continue our discussions on data communications. Here we will talk about the transmissions mode. Now, the another point which you must remember while understanding this part, this video lecture, the data can be presented into a form of signals. So data can be sent as analog data, data can be sent as a digital data. Analog data can be translated into form of analog signal, digital data can be done into digital signal, digital data can be translated into form of analog signals, or four combination we have given you at the end of this slide. The another point which you have to understand, just remember while for this presentation, that when you send a data, there could be a noise on the system, attenuations. The term attenuations was used. Signal strength decreases, and that happens only because of when you send your data for a long distance. Noise, chances of creating a noise on the signals are more. Now let's here move now. Here we are talking about how data is going to be transmitted. This point we didn't emphasize here, there in the previous slide. So data can be translated can be sent parallel, or can be sent as serial. More precisely, we'll go into now details now how it is going to be done now. Data in the form of bit transfer between two or more digital devices. So data is basically in form of bits or in form of a signal. Data transmissions enables devices to speak to each other. That way we have to understand. So when you're sending email to someone else, you are basically talking to someone else. You can do the chatting which people do with your WhatsApp and other kinds of media. Two issues are very important while in data transmission. Wiring and data streams are the main issues. Wiring and data streams, we'll explain these two terms now. What exactly we mean by it is that do we need to send one bit at a time, or do we need to send multiple bits at a time? Now, two methods are there. We can send data serially, or we can send data parallelly. In serial data transmission, data bits are sent one after another. So first bit, then second bit, then third bit, then fourth bit, then fifth bit, like this it will move now over a single wire. So there is a wiring, is only a single wire is there, and if you have to send multiple bits, it will be sent one after another. In parallel data transmissions, multiple data bits are sent at the same time over multiple channels. So for serial, only one channel. For parallel, there could be multiple kinds of channels are there. Now let's understand what is the serial data transmissions in detail. In serial data transmission, one bit follows another bit. Therefore, there is a requirement of only one channel rather than n words to transmit data between two communication devices. Reduces a cost by a factor of n, because here rather than n words we are taking one bit, so the cost is very less. Now this is example of a serial data transmission. So see, we have now here one thing in this picture, you can see how the digital transmission is taking place, how the digital data signal is represented. You have seen how an analog signal is represented in the previous presentation. Here you see that the digital data is represented in the form of a digital signal, and digital signal is represented as a wave form. It is a square wave, something like in a square form. So you see here two types of signals are there in the digital signal. One is the high signal and there is a low signal. So 0 is a low voltage signal, we can say. 1 is a high voltage signal. So one high voltage means 5 voltage. 0 means less than 5 voltage. So wherever you have a 1, the square wave is higher side, higher in amplitude. You can that way you try to understand. So this way the serial data transmission is taking place now. So the way you send the data, the same way data has to be received. This is what we understand. This is what we learn, the basic features of a data communication. You have sent 20 bits, then 20 bits has to be there, and the sequencing also has to be maintained. Here we have seen, you see this signal formation, both sides you will see that same signal, safe signal formation is there at the another side also, or same pattern is being followed in sending the data now. If earlier it was a 0, then first 0 bit should have, then next is 1, then next 1 is here, then followed by 2 0 bits, 2 0 bits here. The same sequencing has to be maintained, accuracy has to be maintained, timing also has to be maintained, and for transmission of this data there is certain protocol inside the system now. Now databases are organized in a specific order, since they can only be sent one after another. This point is important because this comes as a basic feature of data communication. The order of data bits is important, as it dictates how the transmission is organized when it is received. So basically order of the data is important, otherwise it will not be interpreted as the another side now, or the meaning will be wrongly interpreted. A reliable data transmissions method, because a new data bit is sent only if the previous data bit has been received. So these are the important features of serial data transmission. Reliability, the sequencing is important, and it comes as a basic features of data communications. Now the serial data transmission is again two types, what we say is synchronous transmission, and second is called synchronous transmissions. Now let's asynchronous transmission, the timing of signal is not very important now. Data in form of bits can be sent at any point of time, so the timing is not very important now. The control bits such as the start bits and the stop bits are used between the data bytes to synchronize the transmitter and the receiver, and to ensure that the data is transmitted correctly. So there has to be so there is a start bit and there is a stop bit, so that the receiver should get synchronized that this is the first data, data, there is a second data, there is third data. So this way they are synchronized. There might be a gap between each byte. Byte means 8 bits. So they will start bits first, then data 1 byte will be sent, then the stop. It means that 1 byte is completed now. After that there might be some gap, the second byte will be sent. Before sending each byte there has to be a start bit again, and end is a stop bit. So this way receiver and sender are synchronized. They understand this is my first byte, this is the second byte, this is the third byte, this is the fourth byte, and something like this. Not necessarily after first byte, immediately second byte will be sent, might be some gap. Now a start bits and a stop bits and a gap between each byte allows the receiver to synchronize the data stream, just for synchronization purpose. It is called asynchronous because a sender and a receiver do not need to be synchronized at a byte level. This point you have to understand very. Receiver must be synchronized within each byte. So when you send, when you are sending a byte in terms of 8 bits, then the receiver has to get synchronized. Within a byte it has to be synchronized because it has to keep on counting it. This first bit of a byte, this is second bit of a byte, then third bit of a byte, until it gets the stop bit. After that, again, both senders and receiver are not synchronized. When the second byte starts, then again a start bit will start, receiver will now starts counting, then first bit, then after that first bit is going to come. After first bit comes, then he counts whether second bit has come or not, something like this. After second byte is complete, then both are not synchronized. So receiver and transmitter are synchronized within each byte. The start bit, stop bit, and a gap between each byte allow the receiver to synchronize. There is another point which you have to understand here is the parity bit. Even or odd may be also included, ensuring the accuracy of the transmission of the bit data. This is very much important, and this all we are discussing when we list as a part of first video lectures when we talked about basic features of a data transmission. It's not that data has been transmitted, data has been transmitted correctly. That is most important point. Now sometimes there might be noise. Due to noise the signal might be distorted, but how one will come to know that the signal is distorted? So the term is called the parity bit or even parity bit or odd parity. Basically this is check bit. So let's say I'm sending the 1 byte comprises 8 bits. Actual data is 7 bits, and the last bit that will be called as a parity bit. Let's say I assume that parity bit is even parity bit. What exactly it means? It means that the parity bit plus the information bits, the total number of let me repeat once again. I am trying to explain you what is a parity bit. The point which I am trying to make is that data has to be sent reliably. Synchronization is one part, but reliability of the data is another issue which one has to understand. Data has to reach correctly now. How system will come to know, how receiver will come to know the data sent by receiver is correct or not. So one method to check the reliability of a data or correct transmission of data is adding a parity bit. Let's say one example of parity bit I am giving you. The one bit is a parity bit, the last bit is a parity bit. If I have taken as a 8-bit combination where 1 bit is a parity bit, last bit, and 7 bits are actual data bits now. So if it is even bit, then total number of ones in information in data bits as well as the parity bit should be 1. So should be even. For example, I am sending 7-0. Now 7, or let us say 7 ones. If I am sending 7 ones, then parity bit should be 1 because then it will be even number of ones. If I have sent in 3 ones in information bit, then parity bit should have 1 bit. So total 4 ones. So it will be a correct information. I will give one more example. Let's say I have 6 ones and 1 0. 6 ones as a part of information bit. Then in parity bit it will be 0 bit because already 6 ones are there. So total number of ones including parity bit should be 1. This is called even, will be even. This is called. So this is another way of sending the data reliably. A synchronous character may be transmitted one at a time or as a string of a character. synchronizations occurs at the character by character basis level between same thing I am just explaining you. Means one byte is also called a one character. So your name A means one character, and it will take one byte to represent beside in the systems now. And any inaccuracy in timing is corrected when with the arrival of the next character. So these kind of mechanisms are there. At the start bit, receiver, so basically let me just summarize you at the end of asynchronous transmission, that how the asynchronous transmissions takes place. I have given you an example, but here everything is written. Here at the start bit, receiver sets a timer and begins counting bits. After counting 8 bits, it waits for a stop bit. After receiving a stop bit, it waits for another start bit of the next byte. So this way they are both are getting synchronized with each other. Now this is the diagram basically explains you that how the asynchronous transmission takes place. So just notice here one point that when you do the data transmission, when you are sending a data from one to another, then receiver and sender has to be in tune with each other. Means whatever data is being sent has to be received as it is by the receiver. It should be correctly there, and for that there is a kind of synchronization mechanism. And I explain you what is the synchronization. So start bit, stop bit are basically used for synchronization mechanism. Now come to the synchronous transmission. A more sophisticated method of data transmission is a synchronous mechanism. It sends data in a long uninterrupted streams with a predefined start and stop sequence, and not with every character. This is what something overheads are very high in the asynchronous transmission, because with every character you send some kinds of start bit and a stop bit. Here you do not require to do it. So after start bit you can send number of characters you can send now. The start sequences is to alert the receiver of incoming data so that the receiver gets synchronized with the transmitted signal. Now this way we have to just see here in this case data can be continuously, not only one character data, the continuous character, and only the start, and this one is in the beginning. So this is example of a this is illustration of a synchronous transmissions now. Advantage of synchronous transmission: data moves faster than asynchronous transmission, and it is more useful with the high speed application from one computer to another. So where we have a high fast communications to be done between two systems, we use synchronous transmissions now. Now we are moving towards the parallel data transmission. In data communications, parallel transmissions refer to simultaneous transmission of a signal or data. You can send many bits. Data bits are sent separately through different wires and channels. If suppose that I want to say 100 bits, 120 bits, 500 bits separately at a time, then you require so many wires in the system between devices. Transmission of multiple bits simultaneously leads to higher data transmission rate than the serial transmissions now. So this is example of a parallel data transmission. You see that we are sending, let's say if I want to send 1 byte in parallel, then I require 8 bit of wires must be there, physical wire must be there for transmissions, because to carry a signal you require some kind of media. So parallel transmission, fast transmission, but you require more this one. Now advantage is of course speed. Definitely with parallel transmission you require definitely will be speed, because your speed will be increased n times. Parallel transmissions can increase the transfer speed by a factor of n over serial data transmissions. Disadvantage, that the cost will be disadvantaged because you are putting more wires now. And parallel transmission, that is why parallel transmission is limited to a very short distance now. When the parallel transmission is used to send data. That we explained to you, the when amount of data to be sent is very large, when data to be sent is a time sensitive, that it is certain time frame data has to be reached at the destinations, when data needs to be sent very faster. So this way we can have. Now one example to understand what exactly is parallel data transmissions, where we use this kind of transmission. Take example of a video. When video is transmitted to a viewer, video clips need to be received very quickly at the receiver side to prevent a video pausing or a buffering. This always, and this is called a jittering. The term jitter we have used in the previous slide and told that variation of a data delivery from sender to receiver or at the receiver side is called jittery. Means that some packets reach on time, some packets didn't reach on time, and when you watch a movie and there is a jittery, there is a jitter, then you will have this kind of problem. So when video is streamed to a viewer, video clips need to be received quickly at the receiver side to prevent a video pausing or buffering. Video streaming also requires the transmission of a large volume of data. The data being sent is also time sensitive, as slow data streams results in poor viewer experience now. So you always require this kind of transmission if you want to have such a good video streaming facility at your system now. So you try to now, we have explained you so far modes of data transmission, how data is being transmitted now, and in what mode, what kind of situation you use what kinds of modes of data transmissions, and each one has own advantage and disadvantage. So serial data transmission was explained, then we have a parallel data transmission. So now with this we have covered two major topics. One was related to basically what is data, what is a signal, how data transmissions can be defined, what are basic components of data transmissions, what are basic features of data transmissions, some of the important data transmission features again we highlighted while sending the data in a serially as well as data in a parallel. Basic features which drives the or basic important criteria for drives for parallel data transmission or serial data transmission remains the same. The data has to be reached correctly, data has to reach timely, there should not be any jitter, data has to be reached in the same form as it has been sent, or same sequencing has to be maintained both sides now. So the conclusion now, two methods of data transmission. One is a serial data transmission and second is called parallel data transmissions. Serial data transmissions can be classified as asynchronous and synchronous. We have explained you what is asynchronous, what is synchronous. We have given you example of both asynchronous and synchronous, given you a diagram, this one. Parallel data transmission is used when there is a large data is time sensitive and it needs to be sent quickly. So these two video lectures you have understood the basics of data communications and some of its important features. With this way we try to conclude now. Thank you.